Right. So the next method is bisection method. So we have already seen Newton-Raphson method and fixed point method, iterative methods. This is the third one. So Newton-Raphson method is most straightforward. We don't need to worry about the nature of the function. The only condition is it must be differentiable. Its first derivative should exist. That is the condition. Whereas for fixed point iterative method, the form of function also matters. We need to ensure that the function must be converging. Otherwise, it will not work. This method requires even more manual intervention. I mean, we need to identify the interval where the exact solution exists. So that we need to supply. Otherwise, this method will not work. So in this method, this is a most brute force method. Like let's say you are trying to solve f of x is equal to 0. That means you need to identify the location of x where the function becomes 0. So that means, so this is the, you need to get the value of x where f of x is equal to 0. So the simple observation is the value of the function will be negative and positive on either side of the solution. So this is the solution. On one side you will have function value negative, and on the other side function value is positive. And if this is the solution, same situation occurs. Like on one side function will have positive value, on the other side negative value. So you need to identify the interval where the function changes its sign. On one side positive, on the other side negative. So once you supply that interval, then it will identify the solution that exists in between that. Okay. So we'll be bisecting the interval always and reject the unwanted portion. So once you identify this is the interval, you just have to find the midpoint of these two. So these, let's say midpoint of these two exists here. Right? Let's say this is x1 and x2, two solutions. So midpoint of these two will be here. I call it as x3. So now I will exclude the interval x1 and x3 because that portion, in that portion function has both values have positive sign. Whereas in the interval x2 and x3, function sign changes. So I will exclude x1, x3 and keep x2, x3 as the interval. Now again I will bisect the interval. So now I get x4, midpoint of x2 and x3. Then I will exclude x3, x4 in this case. Again I will find out the midpoint of these two, x5. Now the function solution exists between x4 and 5. I will exclude x2. And the process continues till we reach the exact solution. So at every stage we will be bisecting the interval between the two possible solutions. Right, so we have to write this as a program. So now what are the possible ways? Like the user will be asked to enter two numbers. I mean, we have to enter two numbers and we have to check whether the function sign changes or not. So how to identify that? Let's say I am taking this. Program bisect, implicit none, real, f is my function, a and b are my intervals. I call c as a midpoint, and iteration index I. And now I am asking the user to enter two numbers. Enter upper and lower numbers. And I am reading them as A and B. So now we have to check the sign of f of A and f of B and ensure both are opposite. I mean, if one is positive, another must be negative. So how many conditions do we need to write? How many conditions రాయాలండి? If f of A positive, f of A greater than 0 and f of B less than 0. One possibility. Another f of same one, f of A greater than 0 and f of B less than 0. Otherwise f of A less than 0 and f of B greater than 0. ఈ మొత్తానికి ఒక r పెట్టాలి. Right? Is there any other alternative? ఇంకేమైనా పాసిబిలిటీస్ ఉన్నాయి అసలు? అవి కవర్డ్ అవ్వాలి. అండ్ ఒకవేళ ఒకటి సొల్యూషన్ అయిపోతే డైరెక్ట్గా మనం ఎంటర్ చేసిన ఇంటర్వల్ ఇట్ విల్ బి ఈక్వల్ టు 0. ఇట్ ఈస్ నాట్ గ్రేటర్ దాన్ 0, లెస్ దాన్ 0. ఈక్వల్ అన్నప్పుడు పరిస్థితి ఏంటంటే ఆల్ దీస్ కండిషన్స్ ఫెయిల్. So we have to ensure that also. So I am taking the midpoint C is equal to A plus B by 2. So do while absolute f of C ఏం చేయాలంటే ఫస్ట్ ఆఫ్ ఆల్ we have to ensure this part, right? We have to identify the interval first of all. So instead of this condition, if I take product of those two, f of A multiplied by f of B, and if I check the sign of that, what will happen? If both are opposite signs, product will be always negative. If both are of same sign, product will be always positive. Well, we don't need to worry about these many cases. We just try to give so if the product is greater than 0, we have to go back and ask the user to enter upper and lower limits, right? So if f of a star f of b is greater than 0, if both are of same sign, go to whatever. Now we are going to use the first 5-6 columns, 1 to 5 columns. This gives you this is the location of redirect addresses. So you are asking the control to go to 10. It will go there and see whatever instruction exists over there. So, ఏం ఇన్స్ట్రక్ట్ చేసాము? If f of a and f of b product is greater than 0, go to 10. So the process continues till this condition fails. So condition ఎప్పుడు fail అవుతుందంటే only when we enter interval that includes the solution. అప్పుడు మాత్రమే ఈ product less than 0 అవుతుంది. సరే, ఈక్వల్ టు 0 కేసు గురించి మనం ఇప్పుడు మాట్లాడట్లేదు, దాని గురించి చూద్దాం. సో దెన్ ఐఎమ్ డిఫైనింగ్ c is equal to a plus b by 2. And do while absolute f of c ఏం చేయాలంటే ఇది రిక్వైర్డ్ యాక్యురసీ కన్నా ఎక్కువ ఉన్నంత వరకు we have to divide the interval c is equal to a plus b by 2. And again we have to look for this condition. ఏంటంటే if product of f of, let's say I call it as a and b and this is c. Okay, if product of f of a and f of c is greater than 0, so if f of a star f of c is greater than 0, ఏం చేయాలి? we have to exclude a. A is equal to c. Again we have to calculate this, right? C అనేది a plus b by 2 రావాలి. So in place of a, so c becomes, whatever value of c becomes our lower limit. So lower limit will be equal to c. A is equal to c. So that gives this. Then A is equal to c. Else B is equal to c. ఈ ప్రోడక్ట్ గ్రేటర్ దాన్ 0 అయింది అంటే we have to exclude a. So now my a becomes equal to c, lower limit becomes c. Otherwise else అంటే ఏంటి? This product is less than 0. So product is less than 0 means we have to keep both a and c. I have to replace b. Upper limit becomes c. So with that, the process continues till we reach required accuracy. final. C is the solution. And we have to write the function. So this is a very slow model with a convergence rate of 1 by 2 power n. So each time the interval will be divided into 2. So after n intervals we will be approaching 1 by 2 power n levels nearer to the exact solution. So compared to other methods, this is a slower, whereas neutral absorption method is faster in these three. So we keep one end here, and if we want to write the output, maybe here. Iteration I, solution C. Iteration I and solution C, and then you have to raise the value of I, and you have to initiate the value of I. Before the do while loop, you have to initiate I is equal to 0, and after end if you need to write the solution and raise the value of I.